Dear students, after a long time, after a long puja vacation, uh, I come to my YouTube channel. Today, my discussion on concentration. Okay, you use this term. You can use this term, the concentration, in generally in the quantitative analysis. Okay, not only the quantitative analysis in chemistry, concentration is very important throughout your syllabus. Okay, so today my discussions on concentration. Now, what type of concentration terms are there? Clear? In different purpose, we can use the different types of concentration terms. Clear? Now, the first of all, the concentration term, that is percentage. Clear? Percentage. Next one is molarity. This is also very important. Next, molality, normality, formality, ppm means parts per million, and mole fraction. So there is these types of concentration terms is used in chemistry. Clear? Basically, the concentration is used for the solution. Okay? Later, you come to know that the concentration is nothing but the amount of solute or any substance present in a mixture. Clear? Later, basically in the chemical equilibrium chapter, you know the concentration term. Basically, concentration is called active mass. For the solution chemistry, the concentration is used. Okay, but the active mass for the gaseous substance, this active mass is replaced by partial pressure. So today my discussion on the concentration term. So there is lots of concentration term is used in chemistry. First of all, I discuss on the percentage term. Clear? Percentage. Percentage means 100. Okay. There is a various types of percentage term is there. You know, W by W, that is mass by mass percentage, volume by volume, volume by mass, and mass by volume. First of all, I shall represent this percentage term by a pictorial representation. Okay. Now, if there is 100 gram of solution in 100 gram of solution, if the x gram of solute is present, okay, in 100 gram solution, if there is x gram solute is present, so the concentration is x percentage, that is weight by weight. Okay, weight by weight, x percentage, we can write weight by weight. That means here the solution present is 100 gram, that is the mass of the solution, and the solute is present x gram. So this is x percentage, W by W. Next one, if the solution having the volume x ml, okay, x ml, and the solute is present, that is also x ml. Sorry, the solution is 100 ml and the solute is x ml. So the concentration term is represented by X percentage, that is volume by volume. Okay. Next one is, if the solution is 100 gram, if in 100 gram solution, if X ml of the solute is present, so the percentage of the solute is X percentage, that is volume by weight. Okay. Next, the last one is, if the volume of the solution is X ml, 100 ml, and in 100 ml solution, if X gram of the solute is present, so the percentage is X percentage, that is W by V. So there is 4 types of concentration term is there. Clear? Percentage means 100. This medicine, in each 5 ml of this medicine, that contains the levosalbutamol molecule, that is 1 mg, 1 milligram. So in 5 ml, of a medicine contain 1 milligram of levosalbutamol, a solute, a component. Okay, 1 milligram means 10 to the power minus 3 gram of solute. Clear? So in 100 ml, what is the mass of the solute is present? That is 100 into 10 to the power minus 3 divided by 5. That is 0.02 gram of solute. So, what is the percentage concentration of levosalbutamol present in the solution? That is 0.02%. And what is this? Is weight by volume. Weight by volume. That means the mass of the solute is shown here. So, and the volume of the solution. So, this is 0.02 percentage weight by volume. Clear? So, this is the percentage term. Next one is the molarity. This is very important. Molarity. Molarity means, in the pictorial representation, I have shown you, that is in 1000 ml solution. In 1000 ml solution, if there is X mole of solute is present, in 1000 ml solution, if X mole solute is present, so the molarity of the solution is X molar, or it is represented as X molar. Okay. Here X mole of the solute is present. This is very important. In 1000 ml solution, we know that the solution is a combination of solute plus solvent. Clear? Solute plus solvent. So the total volume of the solution is 1000 ml. In 1000 ml solution, if there is X mole of the solute is present, so the concentration is X molar. What is the mole? We know that the mole is weight, any weight of the solute divided by the molecular weight, represented in gram. Clear? So here, that is W by M. So weight of the solute, that is represented in gram, and the molecular weight of the solute, that is also represented in gram. So this is called the mole. Clear? I just tell you, because formula, this is not important. You have to remember the definition of the concentration term. Definition is very important. You can forget the formula. Okay, but the definition and the pictorial representation, these can help you for your future. Okay. Now the molarity means in a particular temperature. In a particular temperature. Particular temperature is very important. Sorry. In a particular temperature, 1000 ml of solution contain X mole of solute. That means W by M mole of solute, where W is the mass of solute and M is the molecular weight of the solute. Clear? So, say for example, in 2050 ml solution, if there is 4 gram of NaOH is present. So, what is the molarity of the solution? This is very important. So, 4 gram means 4 by 440, that is mole of the NaOH. So, in 250 ml, so in 1000 ml of the solution, that is 1000 into 4 divided by 40 into 2050. So this is 10 10 10 10 and 10. So 10 by 50. So this is 0.4 molar. The concentration of the NaOH solution is 0.4 mole. 10 divided by 25. So 2 by 5. So that is 0.4 molar. The concentration of the NaOH solution is 0.4 molar. Clear? By this method, we can easily calculate the molarity of the solution. Next one is the molality. Okay. Same thing, but the difference is here 100 gram of the solvent. Clear? 100 gram of the solvent, not the solution. The previous one is 1000 ml solution, that is the volume of the solution is 1000 ml, but in molality, that is 1000 gram solvent. Here the mass of the solvent is applicable. So in 1000 gram solvent, if there is X mole of solute is present, so the concentration is X molal. Molal is represented by small m. X molal. Clear? So what is the molality? Molality, this is independent of temperature, because the solvent, this is also in the mass. The solute, this is also represented in mole, that means mass. Clear? Mass is independent of temperature. So molality, this is temperature independent concentration term. But the previous one is molarity, this is also temperature dependent. Clear? So molality means in 1000 gram of solvent contain X mole of solute. Clear? This is called the molality. Molality is used in various types of topic. In case of Raoult's law, in Raoult's law, elevation of boiling point, depression of freezing point, at that place you can use the molality terms. Okay. The next one is normality. Normality means, this is very important, because normality is used in the most of the cases. Normality is used for the titration. you know the titration, that is the quantitative analysis. So in titration we know that the uh, equivalent amount of acid that can neutralize the equivalent amount of base, or equivalent amount of oxidant can neutralize equivalent amount of reductant. So there is equivalent amount. So here the concentration term is used as the normality. Okay. So what is the normality? The definition of the normality is, in a particular temperature, in 1000 ml of the solution contain x gram equivalent of solute. This is very important. X gram equivalent. Okay, what is the gram equivalent? That is the W, that is the mass of the solute, and this is divided by the equivalent weight of the solute. Equivalent weight is represented in gram. Okay, so the gram equivalent means mass of the solute, and this is divided by the equivalent weight of that solute represented in gram. Clear? So this is the x gram equivalent of solute. So according to the definition, in a particular temperature, in a particular temperature, 1000 ml of solution contain x gram equivalent of solute. So this is the normality. Clear? This is very important. Here this is also temperature dependent because volume is there. 1000 ml solution is there. So there is the volume. Next one is the formality. This is this is same as the molarity, because mole is comes from the molecular mass, but in case of the formality, the molecular mass is replaced by the formula mass. So for the electrolyte we know that the molecular mass is replaced by the formula mass. Okay, so the same thing as the molarity. Formality is as like as the molarity. So the next one is the ppm. ppm is used to measure the pollution in of the air and the hardness of the water. Okay, so in this case the ppm is used. ppm means parts per million. Parts per million. What is the million? That is 10 to the power 6. Million means 10 to the power 6. Okay. So simply, in 10 to the power 6 parts of the mixture, if the mixture having 10 to the power 6 number of particle. Okay. In that particle, in that amount, if there is x number of solute, x number of parts of the solute is present, so the concentration is x ppm. Okay, this is very interesting. So million means 10 to the power 6. So if you can represent any concentration term by the unitary method in 10 to the power 6 number of parts of the mixture that contains x ppm, x parts of the solute. So the ppm is x ppm. Clear? Next one is mole fraction. Mole fraction. This is very interesting. Mole fraction. Mole fraction is represented by x. Okay. Say for example, there is a mixture A, B and C. Clear? In a mixture A, B, C is present, and in the mixture A having N1 mole, B N2 mole and C N3 mole is present. So what is the total mole? That is N1 plus N2 plus N3. This is the summation of the number of moles of the present in the mixture. So fraction means the mole of one component, the number of mole of one component is divided by total mole. So this is the mole fraction. So simply the mole fraction of A, that is x1, that is equal to n1 by n. N is the total mole, n1 plus n2 plus n3, this is the total mole. The mole fraction of B, that is x2, that is equal to n2 divided by n, and in case of C, that is x3, that is n3 by n. So this is the mole fraction. Clear? In this table we can see there is the components A, B, C are the components. If you take the A component, that is W1 gram, B component, that is W2 gram, and C component, that is W3 gram. If the molar mass of A M1, B M2 and C M3. So what is the mole? That is N1 is equal to W1 by M1, N2 that is W1 by M2, N3 that is W3 by M3. We get the individual number of moles. Now what is the mole fraction? That is x1 for the component A, that is equal to n1 by total mole. x2, that is for the B, that is n2 by n1 plus n2 plus n3, the total mole. For C, that is x3, that is equal to n3 by total mole. So this is the mole fraction. Mole fraction, this is also very important concentration term. So I just discuss only the definition of the various types of concentration term. I request you to remember the definition exactly. Okay. There is a lots of formula in your textbooks. You can read this one, but if you forget the formula, the definition, the actual definition can help you to understand and to define the various types of concentration term. Many of the students can forget about the what is the molarity, they cannot calculate. What is the normality, they cannot calculate. But you have to know the definition. So in the normality, say the normality of the of a solution. Say for example, normality. Okay, there is 100 ml 2 normal H2SO4. Okay, 2 normal H2SO4. Now in 100 ml there is 2 normal H2SO4. What is the amount of original amount of H2SO4 is present is there? So we know, according to the definition of the normality, that is 1000 ml 1 normal H2SO4 contain the equivalent weight of the H2SO4, equivalent weight. What is the equivalent weight of the H2SO4? That is 98 is the molecular weight, and this is divided by 2. 2 is the number of replaceable hydrogen, okay, for sulfuric acid. So that is 49. So 100 ml 1 normal H2SO4 means the equivalent weight of H2SO4, that is represented in gram. Okay. Now 100 ml 2 normal H2SO4 means 49 into 2 into 100 divided by 1 into 1000 gram of H2SO4. So that is 10, and this is 98 by 10, that is 9.8 gram of H2SO4 is there in 100 ml 2 normal H2SO4 that contains 9.8 gram of H2SO4. So, if you know the actual definition of the concentration term, you can easily calculate this one if you remember the formula of the concentration term. Clear? So, this is my today's discussion. Thank you. Please subscribe my channel and give some valuable comment. If there is any query, you can write in the comment box. Thank you.